Hey there, welcome to Unit 2. In this video, we're going to be talking about properties of waves. Below, I've drawn a sample wave. With every wave, you're always going to have the highest value of the wave, or the topmost part of the wave, and that part of the wave is called a peak. Likewise, you're also going to have a bottommost or lowest value of a wave, which is called a trough. T-R-O-U-G-H. The distance between one peak to another peak is called the wavelength. The wavelength is also sometimes represented by the Greek symbol lambda, which looks something like that. Wavelength also applies to the distance between trough to trough points of a wave as well. A wavelength can occur at any part of a wave, not just at peaks and not just at troughs. So it can occur right here at this point, at this starting part of the wave, and then it repeats itself right here. So this up to here is a wavelength. However, a common misconception that often occurs is sometimes people think that this point to this point is a wavelength. That's not true, because it's not a repeating point. From here to here, it's a repeating point, because at this point, you're coming up, you're going down, and then finally, you're coming back up. So you're repeating the process of going up, going down, and then coming back up. So if I draw a point right here, you'll see that it stays kind of stagnant over that course. That is considered a repeating point, thought of as a wavelength of a function. Similarly, a point right here to a point right here is considered a wavelength. One type of property that can be used to describe waves is called frequency. Frequency is the number of cycles that occur in a wave per 1 second. Okay, so let's say we were somehow able to get a graph of a wave, and we took a snapshot of this graph for only 1 second. And someone asked us to calculate the frequency of this wave. What we would do to calculate the number of cycles is basically look at the number of wavelengths that occur in this 1 second. So this 1 second lasts from the start of this black line to the end of this black line. So if we had to calculate the number of wavelengths, we can do it at any point that we want. It doesn't have to be a peak or a trough. So in this case, I'll just do it from a trough. So we have our first trough to our second trough. That's one wavelength. That's our first wavelength. And then we have this trough to this other trough, and that is our second wavelength. So if I had to answer the question about the frequency of this wave, I would say that this wave has a frequency of 2 cycles per second. Now, instead of saying cycles per second all the time, scientists created a unit that represents this term. The unit is called the hertz, and it's abbreviated using the term Hz. So if I had to rewrite this whole thing, I would say that this wave has a frequency of 2 hertz, and that would be my answer. Frequency is also often commonly stated using the term V. Another term that is used to describe waves is called the period. The period is the complete polar opposite of a frequency in the case that it means it is the amount of time it takes for one cycle to happen. So in this case, if we scroll back up to our initial 1 second snapshot of our wave, we want to calculate the amount of time it takes for this wavelength to happen. Well, earlier we said that in total there were 2 cycles that occurred in this wave. So if I had to calculate the amount of time it took for one cycle to happen, then all I would need to do is I would need to do 1 over the amount of cycles that happened. And that would be the amount of time it took for one cycle to happen. So in this situation, one cycle happened every 1.5 seconds. And that makes sense because for this first cycle to happen, that would take 1/2 second. And then for this second cycle to happen, that would take another 1/2 second. And if I add these two terms together, that gets me in total 1 second, which is exactly how long our snapshot was. The period and frequency are complete polar opposites of each other. In fact, they're inverses. So we would say that the frequency is equal to 1 over t, which is the symbol that is used for period. One last property that you should know is the amplitude. The amplitude is the distance between the crest of a wave or a peak of a wave to the center line, and it is also the distance between a trough or bottommost part of a wave to the center line as well. In a properly drawn wave, unlike this one, the distance from the trough to the center line should be the exact same as the distance from the crest to the center line. So the amplitude is the exact same no matter where you take it in a wave. Amplitude is often related to the intensity of a wave or the amount of energy a wave has. And with that, we wrap up this video. I hope you enjoyed it, and I'll see you in the next one.